continue that way until it gets to the ground. And the moment it gets to ground, do not forget that the time taken from this point of projection down to this point is the time of flight. While the time it takes from here to get to the maximum height is the time to reach the maximum height. And the total distance covered, that is the total vertical distance covered, is your what? Maximum height. Then the total horizontal distance covered after it has been projected is called your range. Now, this is for vertical projection. Then this is for horizontal projection. Horizontal projection. So here, I'm going to be having horizontal projection here. This is for horizontal projection. Projection. Yes. Now, this is where WAEC normally asks questions and you see students messing up. They miss words and they lose a lot of marks. You see here, this body is actually on top of a tower. The moment this body moves, it's going to be having an horizontal speed. It's going to be having an horizontal speed. I can call that ux, and I can just say it's u. Do not forget, under this vertical projectile, the horizontal speed of projection is u cos theta. But horizontal speed for horizontal projection is just u. And that is the speed at which it was what? It was being hit, or it was is the speed at which that body is allowed to move from the top to the ground. Now, from here to this point is your height. That is the maximum height covered. Maximum height covered. Now, you see the time it takes from here to here is your time of flight. Is your time of flight. And we make use of equations of motion to solve questions on this. Yes. Another thing is this. If a body is here, let's assume you have two bodies. One is allowed to move this way, and the other one is allowed to drop directly from the top to the ground. It will interest you to know that these two bodies will get to the ground at the same time, provided there is no air resistance. Thank you. Please, that is a key word. No, so in that case, as we move on, I'll be deriving some formulas for this. So let's leave that. Now, another thing is projectile motion can be treated in terms of two perpendicular components. You know, I mentioned that. The first one is your uniform horizontal speed, which is the horizontal acceleration, is 0. That is, when this body is what? Is undergoing horizontal projection, the horizontal acceleration of that body is 0. Now, the another condition is that there is a free vertical motion under gravity, whose acceleration is thus equal to the acceleration due to gravity. These 2 points are very, very important when dealing with two perpendicular components of projectile motion. Now, if I take this up a bit, there is something I do call, or I personally, I call them the two balls. Everything here is called the two balls under projectile. That means before I solve any question under projectile, I'm going to ask myself some questions. Do they actually have everything that I'm saying here? If they don't, I know what to pick. Now let's see. For horizontal component, I have my ux to be equals to what? U cos theta for initial velocity, and for vertical component, I have u sin theta. But for acceleration, horizontal component, if you can remember, I said is what? 0. But for vertical component, when the body is going up, acceleration due to gravity is negative, and when the body is coming down, acceleration due to gravity is positive. Then there's something we call instantaneous velocity. Instantaneous velocity under horizontal component is equal to what? The initial speed, or the initial yes, the initial component of its speed. But under vertical component is equals to u sine theta minus gt. Now, don't forget that your ux is equals to what? U cos theta. So if I'm asking for the instantaneous velocity, how do I mean? Instantaneous velocity at a particular instant, at a particular time, I will just say is equals to what? U cos theta. But if it is for vertical component, I must what? Include minus gt into it. Now, the last but not the least will be the distance covered in time t. You may want to put that as what? As the instantaneous distance. And that is what? Or you call it range. Under horizontal component, we call it range. It's just ut cos theta. But under vertical component, it is y equals to ut sine theta minus half gt squared. You will see how I'm going to be applying all these formulas to solve some questions. Now let's see. Trajectory is the path a projectile follows through space as a function of time. And of course, I have the formula there, which is y equals to tan x minus g over u 2u squared cos squared theta multiplied by what? X squared. Now, there's something very, very interesting concerning trajectory. That's the equation of trajectory. It's, if you check it very well, you will see that it actually follows the pattern of quadratic equation, of a quadratic equation, in the sense that you have the x squared and you have the what? X. Now, don't forget that whenever you are plotting a quadratic graph, when the coefficient of the x squared is negative, that is minus a, if you want to go by that, this is how the graph will look like. But if it is positive, it will look like this. But you agree with me that in this case, it is negative. So I'm going to go by this. And of course, if you are to look at the direction of trajectory, is actually in this format. And I actually gave an hint on how you can derive this. All you need to do is go by the way of what? The instantaneous distance covered, which is the horizontal distance covered, make t the subject of formula, and substitute it into the distance covered in a particular time for the vertical components, which is y equals to u sine theta multiplied by t minus half gt squared. If you substitute this into this, you will get this equation.